Hello and welcome back to my channel once again. I remain your online tutor, Mr. Eze. Now from today henceforth, I will be taking us on mathematics and physics on this channel. So for you to get all the knowledge you need, both to revise your lesson at home, to teach your kids at home, follow me on this my channel and my social media handle, my Facebook, Sir Eze Physics and Mathematics online class. Follow me there so that you will be getting updates on regular basis. Now, today I want us to look at the mathematics instead of physics. Today we are looking at mathematics, and the topic I want us to look at is probability. Now, before we proceed, if you have not subscribed to this my channel, please hit the subscribe button, hit the like button, and then share this video with your friends. All your friends that are within school age, share it with them, because mathematics is a general knowledge. It's a universal subject. Okay, now let's go. Probability. What is probability? So probability is a numerical measure of the likelihood for a specific event to occur. Now, for this event to occur, it can be represented numerically between 0 and 1. Now, if we have a numerical value of 0, it means that the likelihood for that event to occur is very slim, is very small. Now, if you have a probability of 1, the likelihood for that particular event to occur is 100% certain. Now, we proceed. Now, this probability can be written, the formula, probability of a particular event, let's say probability of an event occurring. Of course, it is equal to the expected outcome. Expected outcome all over the total outcome. All over the total outcome. For example, if a die is tossed once, and of course we know that a die has 6 sides. The 6 sides, of course, each of them has a particular figure. For example, if this is a die, now this is a die here, this is a die also. Now, this side can contain 1. This side can contain 2. This side can contain 3. Remember, 1, 2, 3. It has other faces, 3 other faces. So, the expected outcome there is any side that you desire, while the total outcome is all of them. So, for here now, you count here as 1, count here as 2, count here as an independent value, which is 3. Now, if you count all the 6 values, you have 1, 2, 3, 4, 5, and 6. So each of these represents an expected outcome. But all of them will have 1, 2, 3, 4, 5, 6. The total outcome there is 6. That one is number 1. Number 2, assuming we have a coin assuming 2 coins are tossed. If you toss 2 coins, of course, the possible outcome there will have the head and the tail. Now, 2 of them, assuming we have 2 coins, A and coin B. Now, the first, the probability of getting maybe head and the A to be head and then this one to be head, this is 1. Now, assuming A become tail, you get this as tail and this one is head. Now, assuming we get this one as head and this one becomes tail. Now, assuming we have tail for this one and tail for this one. 1, 2, 3, 4. Now, the possible outcome here, you can have both as head, one is tail, and the other one is head. The same thing is go to this, and the same thing is applicable to this. Now the total outcome here is 1, 2, 3, 4. The total outcome here is just 4. Now, having discussed all this, now let us take one or two calculations. Now let us look at this question here. 2 coins are thrown at the same time. Find the probability of getting both heads. Now, the probability of getting both heads, like we said in the introductory aspect, that once you have 2 dice, or sorry, 2 coins, if you have 2 coins, what the possible outcome there, or the total outcome there, will have head and head, tail for this one, head for this one, maybe head for this one, tail for this one, and we'll have both tails. So the total outcome here is 4. Now the probability of getting both heads, the 2 times, assuming maybe you just toss it, the first one you get both heads, of course it is 1 out of these 4. Therefore it is 1 over 4. Now 1 over 4, and of course 1 over 4 is option B here. Therefore the correct option here is option B. Now let us take another question. Let us look at this question. This question says, what is the probability that a number selected from the numbers is, this is the number. There are 2 questions here. That the first one is a multiple of 4. Second one is a prime number. Now, they say 1, 2, 3, up to 15. All we need to do is to express those numbers one by one. So we have the solution here. The first thing we do is to write out these numbers. The content of these numbers are, we have 1, 2, 3, 4, 5. You continue until you get to 15. 6, 7, 8, 9, 10, 11, 12, 13, 14, and finally 15. So this can now help us to solve this problem. Now the first question says, what is the probability of selecting that the number selected is a prime number? Now, is a multiple of 4. What are the multiples of 4 from these? So the first thing, you list them out. This one is a multiple of 4. Now how do we know the next multiple of 4? Add 4 to this, and we'll have 1, 2, 3, 4. That means 8 is a multiple of 4. Let's find out if we have another one left. Add 4 to this. 1, 2, 3, 4. We'll have this. And then let's see if we can have another one. Of course, 1, 2, 3. We don't have any other one. That means multiple of 4 in this range is 1, 2, 3. Therefore, the probability of selecting a multiple of 4 from this range is 3 all over. Now you count how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Remember the rule. Expected outcome all over the total. The total numbers there 15. While the expected is just 1, 2, 3, 4. Therefore, they will have it as this. But then if you look at this, you can still move down a little bit. Therefore, 3 can cancel to give you 1. 3 can cancel 15 to give you 5. Therefore, the probability of getting a multiple of 4 is 1 over 5. All right, this is the answer. Now, the next number now, which is the number 2. The number 2 there is the probability of getting a number that is a prime. Now, what are prime numbers? That is the first question we'll ask ourselves. What are prime numbers? Prime numbers are those numbers that can only be divided by 1 and themselves. I repeat, those numbers that can be divided by just themselves and 1. For example, 1 can only be divided by itself, and then 1 cannot divide it. Now, of course, 2 can divide itself, and 1 can also divide it. 3 can divide itself. Of course, 4 is not a prime number. So we erase this one, erase this, and erase this. So those ones that are prime number, let us start with them. 1 is a prime number, 2 is a prime number, 3 is a prime number. 5 is a prime number because it's only 5 and 1 can divide it. Which other one? 6 is not a prime number. 7 is a prime number. 8 is not a prime number. 9, of course, 3 can divide the 9. 9 is not a prime number. 10 is not a prime number. 11 is a prime number. 12 is not a prime number because another number can divide it. 13 is a prime number because 13 and just 1 can divide. Of course, out of this now, this other one, 14 is not a prime number. 15 is not a prime number. Prime numbers here are 1, 2, 3, 4, 5, 6, 7. Therefore, the probability of getting a prime number, is 1, 2, 3, 4, 5, 6, 7. 7 all over the entire number. Entire number is a 15. And of course, 15 is a correct answer for this. While 1 over 5 is the correct answer for the first one. This one is 7 over 15. And we cannot reduce this anymore. So we'll leave it like this. Okay. Please share this video with all your friends, especially those in secondary school that are struggling to learn probability. Now, we'll take the next question. We look at this number 3 question, and this question says, a box contains 2 red, 2 blue, and a yellow marble. What is the first question? The percentage probability of picking out a red marble. Second one, a blue marble and then a yellow marble. If the marbles are returned, if the marbles are not returned to the box. Now we'll answer them one after the other. In the first question, remember the formula, the formula for probability. We said probability of an event occurring is equal to expected outcome all over the total outcome. Now, in this case now, the total outcome is the number of marbles in this box. So number of marbles, we have the red marble. Red marbles are 2. The blue marbles are 2. Now the yellow marbles are 1. Total marbles here we have 5, which is the expected outcome. Now which is the total outcome? The expected outcome now is what is the percentage probability of picking a red marble. Since there are 2 red marbles there, now the probability there of picking red marble, that means probability of red is equal to the total, which is 2. Total of red marbles there are 2 all over the total of the marbles there. 2 over 5, and of course 2 over 5 will give us 0.4. Remember the question said what is the percentage? Now 0.4, so that means 2 over 5 of 100% will now give us this over this is 0.4. When you now multiply it by 100, therefore the probability of picking, the percentage probability of picking a red marble there is, and of course this time this will give us 40%. So the possibility of picking a red marble from this is 40%. For the second question, they said here, what is the percentage probability of picking a blue and then note this, what you have and means that you multiply. So the percentage probability of picking a blue and a yellow marble. Now we have that probability of picking blue and the yellow is probability of blue first. Remember, here they said if you pick the first one, you don't return it, you pick the second one. So the probability of picking a blue, of course, probability of picking a blue is number of blue. We have the 2 all over the total number 5 multiplied by the second one now yellow. Remember, the first one we pick, we did not return it. This one is, remember the question, these are independent questions. This and this are independent of each other. So do not say that yes, this one is brought in. No. This one we are dealing with 5 entities. From there we have picked the first one. Now the second one says yellow. Of course, there are just one yellow marble. We have 1 over. We didn't return the first one. We have 4 remaining. So we have times 4. Which will now give us 2 times 1, 2 all over 5 times 4, 20. Which will now give us, if we move down, we have 1 over 10. Therefore, the probability of picking blue and yellow without replacements or without returning any of them is 1 over 10. 1 over 10 is 0.1. This 0.1 multiplied by 100%. Remember, the question says percentage probability. So the percentage probability of picking blue and yellow without replacement is 0.1 times 100. And of course, which will give us 10%. Now, the likelihood to pick this, the first one blue and the second one yellow without returning the first one is 10%. But if you are asked the probability of picking the first and the second, of course this is the probability 1 over, then the percentage probability is this 10%. Please like and follow this page for more videos. Okay, this is where we end the lesson for now. Please follow me in my next video so that we will do more of this. Thank you.